Hello dear student, this is Deep Narayan Singh. In this video, we are going to discuss the Unit 4 of your subject Artificial Intelligence. In that, we will discuss evaluation parameter and most important topic, that is confusion matrix. 100% question is going to come from that part in your board exam. So if you see this video, definitely you are going to get at least 2-3 marks in the artificial intelligence subject board paper. Okay, so let us go ahead and see what are the parameters that are used for the evaluating a model. Okay, and we have seen one introduction video already on my channel. So if you have not seen that video, just go and check out that video first, so that you can get a good understanding of this video also. So what are the parameters for evaluation? Let us see. Now let us go through all possible combination of prediction and reality. So what is prediction and reality? Prediction is the output of our AI model which we have created, and reality in actually what is the situation as we human beings know. So for the data, what is the output should be? So what is the input data we are giving? Actually the output that we want from our AI model, that is reality, and this the output of the AI model is called what? Prediction. Okay, let us see how we can use these conditions to evaluate the model. Okay, so there are 4 very important evaluation parameters. First one is called accuracy, precision, recall, and F1 score. These are methods of evaluation or evaluating any AI model per se. तो अब हम आगे चलेंगे और देखेंगे कि कंफ्यूजन मैट्रिक्स कैसे काम करता है. लेट अस सी द कंफ्यूजन मैट्रिक्स. Okay, so what the confusion matrix is in itself, the comparison between the result of prediction and the reality is called confusion matrix. So when we compare prediction and reality in a tabular form, then it is called what? Confusion matrix. And let us see how it is made. So this is a skeleton of that matrix. We will write confusion matrix here, we will write prediction on that place, and reality here. I told you already that all the combination of prediction and reality, how to evaluate the answer for that. So reality can have no means a negative input, or yes means a positive input. So we will try to understand this using an example. Same example we have taken in previously. Like this is our AI model, and we are trying to predict by giving a photograph to it or picture to this AI model and asking the AI model, is it a picture of bird or not? But as we are human beings, so we already know that it is a picture of bird or not by seeing it. But what our AI model gives in the result, that will be what? Prediction. And this is the information which we have by seeing the picture, that is called what? Reality. So in itself, if it is a picture of a bird, then we will say reality is yes. If it is not a picture of bird, we will say reality of no. Okay, if our AI model predicts it is a picture of bird, we will say yes. Or if our AI model predicts it is not a picture of bird, then we will say no. So these are the 4 possible combinations that can be generated. Like if it is, we will write here prediction or reality. So prediction may be no, and reality may be no. Prediction no, reality may be yes. Prediction is yes, reality may be no. Or prediction is yes, reality is yes. Okay, or we can say that prediction is yes, reality is no. So these are the 4 possible combinations that can be generated. So I told you, when prediction and reality both matches, first word is what? True. And if prediction is no, next word is what? Negative. So first column will have what? True, negative. I hope you got it. For the next column, reality and prediction are not matching. We are talking about this column. So first word is what? False. And as prediction is no, so the second word will be what? Second word will be negative. So we will see here, this will be what? False negative. We are talking about this particular column. Okay, so this will be what? False negative. Let us see for this one. Okay, so here in this particular cell, reality is what? No. And prediction is what? Yes. They both are not matching, so first word will be false. And as the prediction is yes, the second word is what? Positive. So in that way, the last cell we will see, prediction and reality both are yes. So we will have what? First word as true, and then as the prediction value is yes, so second word will be positive. In that way, I hope you people are able to fill this uh, values of prediction and reality. Let me erase some of the ink from this slide. Okay, so I will choose eraser and try to remove this ink from there. So this is our complete confusion matrix. Based on that confusion matrix, how can we write the formulas for our uh, evaluation parameters like accuracy, recall, precision, and F1 score? So that we need to see. Remember, you should write reality and prediction in the same way, and values for it, no, you will write first, and yes, you will write second. In reality also, no, you will write first, and yes, you will write second, so that you will get the correct combination, and you will remember this matrix by writing multiple times in the same format. I hope you understood how these words are coming. If reality and prediction both are having the same value, first word will be true, and next word will depend on the prediction value. If it is no, next word will be negative. If prediction value is yes, next word will be positive. In that way, you are able to fill that confusion matrix in values in these cells. Let us see the first formula. Here you can see we need to consider these two cells. Okay, these two cells, this one and this one, true positive, and you have what? You have true false negative. So these two things you need to have in mind: true positive and false negative. Fine. Then this is what we are considering, these two cells for recall. Let us see the formula of recall. So we know this is a denominator of it. Whatever I am denoting here, this is a denominator. So this particular column will be act as denominator for recall purpose. Forget about the definition, we will discuss later. Okay, TP and plus Fn will be in the denominator of the recall. And what is in the numerator? Numerator is what? TP. Okay, so I hope you got an idea. If you make confusion matrix correctly, then denominator, you know that the last column values will come in the denominator of recall, and the numerator is what? TP. Then you go for next parameter, that is precision. So now we are considering the last row. We have considered this column for recall, and this row we are considering completely for precision. So this column for recall, and here we are considering this for precision. Let us see the formula of precision. Numerator is same for precision and recall, that is TP only, but the denominator is different. So what is the denominator? Denominator is last row, that is TP plus Fn, FP, sorry. So here you have true positive plus F positive, false positive, that is available in the last row. So these two formula I hope is very clear. For recall, you need to consider the last column, and for precision, you need to consider what? The last row. Now there comes the accuracy. So for accuracy, you need to consider this diagonal. Okay, this diagonal comes in numerator. कहाँ पर आएगा बेटा? ये numerator में आएगा, and denominator will be all four cases. All four cases, TP plus TN plus FP plus FN. So it is very easy to remember the denominator of accuracy. And what is numerator? Numerator is principal diagonal. For any matrix, this is called what? Principal diagonal. Okay, so if I will write a matrix like this, then this is what? A principal diagonal of it. So that will come in the numerator. Here you have true negative in the numerator and true positive in the numerator. I hope you people are getting it. Give it a shot and see properly rewind the video and check out. Numerator of accuracy is what? The principal diagonal, that is true positive and true negative. So that's why intentionally we have taken this no first and then we have taken this yes second, so that our these values will come in a sequence where we can uh, make some pattern into it. Recall के लिए बेटा लास्ट कॉलम देखना है और प्रेसिजन के लिए लास्ट रो देखना है, एंड दीज बोथ आर कमिंग इन द डिनोमिनेटर ऑफ द फॉर्मूला, एंड न्यूमरेटर विल बी व्हाट? precision and recall के लिए true positive will be numerator, so that will be same. And for accuracy, denominator will be what? That will be principal diagonal, and where what you have in this diagonal? True positive and true negative, and the denominator is what? All four cases. So it is very easy to remember all four cases like Tn, Tp, okay, and Fp and Fn. So these are the three formulas for your evaluation parameter, and last one is what? F1 score. So F1 score is very simple. F1 score is a measure that balances create a balance between precision and recall. So 2 into precision into recall, and in denominator you will have precision plus recall. So you need to have in mind that in numerator you have the sign of multiplication, and in denominator you have the sign of addition. Like that you can remember this F1 score also. I hope you people will get. Still, if you are having any confusion in creating this matrix, do let me know in my comments. I will give another shot to explain this one, but I hope it is pretty much clear for all of you to understand it. Let us go ahead, and I have one more request to all of you. If these videos are helping you out in your preparation, please do like, share and subscribe this channel. It gives me a great motivation to create new content for you people. I hope all of you are doing that. If not, please do like, share and subscribe this channel. Let us go for the first evaluation parameter, that is accuracy. And accuracy is defined as the percentage of correct prediction out of all observation. So out of all observation, what are the observation? All four cases we will take in the denominator. Okay, so maybe Tp plus true positive, then true negative. Okay, so Tn plus false positive plus false negative. Okay, so there you have what? False positive plus false negative. And in denominator you have Tp plus Tn. So in numerator you will have what? Tp and plus Tn you will have in the numerator. Okay guys, so you will have like Tp plus Tn. My pen is not working fine, that's why it is creating some problem. Please do bear with me. So again we will read the definition. The percentage of correct prediction out of all observation is called what? Accuracy. Read it 3, 4, 5 times so that you can just understand it properly. Correct prediction out of all observation is called what? Accuracy for any AI model. The prediction can be said to be correct if it matches with the reality. When your prediction is said to be correct, when it matches with the reality. So it is actually another way of saying where your prediction is equal to reality. In these cases only what you will have? T as a true as a first word. So that's why in numerator you will have all the cases where you have true as a first word. True positive plus true negative, and in denominator you have all the observation. Fine, I hope you are getting. Here we have two conditions in which all predictions matches with the reality. These are the two conditions, true positive and true negative. Okay, fine. So here you have true positive and true negative, where your prediction is yes, reality is yes. When model predicts yes, and when it matches with the reality, which is also yes. Hence this is a condition of true positive. And true negative, when prediction says no, reality also says no. When model prediction is no, and when it matches to the reality, which is also no. Hence it is a condition of true negative that comes in the numerator, and denominator all possible combinations. Again I will make a small confusion matrix for you people so that you can remember. Here I am writing prediction, here I am writing reality. Okay, and then you have what? No, and you will have yes. For reality you will have no and yes. And in that case if I make a matrix form here, you will have 4 cases available. For first one, no and no. So what prediction and reality both are matching? First word is true and prediction is negative. So second word is what? False. Oh, sorry, true, negative. So this is a case of true negative. Then in for this column, reality is yes, prediction is no, both are not matching, so it will have the false. And as your prediction value is no, so it will have negative, second word. And there for this column you will have reality as no and prediction as yes, both are not matching, so first word is false. And as prediction value is yes, so the second word is what? Positive. And then you will have what? Reality as yes and prediction is yes, both are matching, so first word is true and next word depends on the prediction value, which is yes, so again it is going to have the value as positive. So this is what your confusion matrix is. I hope you people are getting it properly. Let us move ahead to the next slide that says the accuracy formula. Hence, the total observation covers all possible cases of prediction that can be true positive, true negative, false positive, and false negative. That comes in the denominator. Correct prediction out of total cases, and that may be represented as Tp plus Tn upon Tp plus Tn plus Fp plus Fn multiplied by 100 will give the answer in percentage. You might multiply or might not multiply, both are correct. For example, if you can say, let us assume the model always predicts there is no football. Remember from the last video which I have uploaded in the evaluation unit, but in reality there are 2% chance of the football. In that case, case for 98 cases, the model is right, but for 2 cases which there was a football, then the model predicts there is no football. So in that case, what should be the accuracy? Remember the formula uh, that correctly identified cases out of all cases. That is our, so there we have the image of football, and there true positive cases, how many we have? True positive cases comes when your prediction and reality matches with each other, and prediction is what? Yes. So we do not have any such case. Why? Because it is saying no football. So the prediction value, it is wrong for 2 cases only, where reality is what? Yes, but prediction is saying what? No. So these are the 2 cases where it is creating a problem. Okay. So in that particular case, what actually happening? There you can find true positive is 0, but this is a case of true negative. As the prediction value is no, so the second word will be what? Negative. So 98% it is fine. When for the 98 cases, it explains or it tells correct, it gives the correct output. Okay, so 98% cases, but how many total cases are there? 100. So what will be the accuracy? 98 plus these are the cases, 98 cases of true negative. Why? Because where prediction is equal to reality, and prediction and reality both are no. Prediction and reality both are what? No. So these are the cases of Tn, and these are the cases of TP, where prediction and reality are matching, and reality saying yes. So there is no such case where prediction and reality are matching and reality is also yes. Okay, so in conclusion, prediction always no, reality 2% probability of yes, accuracy is what? 98%. In that way you can calculate. This is fairly high accuracy of AI model, but this parameter is useless for us, as the actual cases where it was a football was not taken into account. Hence, there is a need to look for the another parameter to take that in account of such cases, because it is predicting correctly for all the cases where there is a not there is no football, but it has not considered at least a single case where there is a football and our AI model has predicted it correctly. तो ऐसा कोई भी केस नहीं मिला. तो accuracy in itself is not sufficient parameter to evaluate any model. If it is becoming too complex, don't worry, If you listen it properly, definitely you will get. Let us go for the next parameter, that is precision. Precision, the definition of the precision says the percentage of true positive cases, as percentage of true positive cases versus all the cases where prediction is true. So what happens where prediction is true? Where prediction is true, second word is fixed. Okay, that is what positive or positive only. Second word is fixed, where prediction is true. And true positive cases means what? Where you have prediction is equal to reality, that's why the true comes. And predicts in prediction is also what? Yes, that's why this positive comes. So this is a case of true positive versus all the cases where prediction is true. That is the definition of your precision. Prediction is yes, reality is yes. When the model predicts yes, when it matches with the reality, which is also yes, hence the condition is true positive. And then this is our numerator. So TP is what? Numerator. And in denominator, what goes? In denominator goes like TP plus you have Tn. Oh, sorry, uh, Fn plus Tn. Okay, so Fn plus Tn. Remember in numerator. Next case is what? False negative. Prediction is yes, but reality is no. That is a case of Fn. They both are not matching. That's why the first word is false. And as the value of prediction is yes, the value for the value for second word must be positive. So there you go, this should be what? Positive, because that is the value, prediction value is what? Yes. So that will should be false positive. What should be? False positive. It is wrongly written there. All the true positive cases versus all the cases where prediction is true. Now see the precision formula. True positive cases out of all predicted positives, and it can be written in this way: TP upon TP plus FP. So in confusion matrix also, I will again draw it here. And let me erase some of the ink so that you can understand it properly. Erase. Okay, fine. Let us select the pen again. Here you have prediction for which you have no and yes, and you have a reality for which you have no and yes. So how will you fill this matrix? No means true, negative. Second word is what? Or prediction value is no. So second word will be negative. Both are not matching. So first word is false. Second word is what? Negative, because prediction value is no. Both are not matching. Second word is false and the first word is false. And next second word is what? Positive, because the prediction value is yes. I told you second word will depend on the prediction value, and first word will depend that reality and prediction value are matching or not. Here what you have? Here you will have both are matching, so true, and precision value is yes, so this is positive. And for precision we need to consider the last row. So you can see FP plus TP will come in the denominator, and numerator for precision and recall both are TP. This is the short form to understand the formula. Okay, going back to the football example, in that case, assume that the model always predicts there is a football irrespective of the reality. In that case, positive condition would be taken into account, true positive and false positive. In this case, player will check the ball all the time if it is a football or not. Uh, so which means if the reality is true or false. So it, regardless of the reality, player need to check that ball is a football or not. You might recall a story of the boy who falsely cries out there is a wolf every time. So when they actually arrive, no one comes for his rescue, because it is creating false positive cases more. Similarly, if the precision is low, which means there are more false predictions than the actual ones, this means player would get complacent and might not go check every time, considering it would be false again. This story is very famous. If you give quite a concentration on that, कि एक बच्चा था वो बार बार कहता था भेड़िया आ गया तो गांव वाले दौड़ पड़ते थे, लेकिन एक बार सच में भेड़िया आ गया तो गांव वालों ने सोचा ये तो हमेशा ही झूठ बोलता है। तो ऐसा ही कुछ हमारे मॉडल के साथ हो रहा है कि अगर वो बार बार झूठ बोलेगा तो क्या होगा, कुछ टाइम के बाद हम लोग उस पर विश्वास करना बंद कर देंगे और देयर प्रिसीजन विल go down. Okay, so the issue is there with this precision parameter alone also. So we need to go for some more parameters. We will see a note: if precision is high, that means true positive cases are more, giving lesser false prediction. So if precision is high means true positive cases are more and it is giving lesser false prediction. तो अगर प्रिसीजन हाई है तो बच्चा तभी चिल्लाता है जब वहां पर भेड़िया आया हुआ हो, अदरवाइज वो नहीं चिल्लाता है। ओके, इन द रेयर केसेस एक आध दो इंसिडेंट ऐसे हो जाए वो एक अलग बात है, बट मोस्ट ऑफ द केसेस इफ देयर इज अ वॉल्फ देन ओनली योर चाइल्ड इज or your that particular naughty boy is going to raise or cries. So in that case your trust remains and you will always go and check out if there is a wolf or not. Like that same situation happens with our AI model for the precision. Let us go for an example. Prediction 10 cases are of true positive, reality 20 cases are yes. So accuracy, what 100% you have the accuracy. Let us consider that the model has 100% precision. This means whenever the machine says there is a football, there is actually a football. That are the true positive cases. In some model that can be rare exception cases where there was a actual football but the system could not detect it. This case is called false negative conditions. Okay, but the precision value would not be affected by it because it does not take false negative into account. Because if you see the precision formula, it will not take false negative values into account, fn. And when fn is generated, when prediction and reality are not same and prediction value is no. Okay, so we need to go for some more parameter. There we see the recall. The fraction of positive cases that are correctly identified is called what? Recall. The majority takes into account the true reality cases, whereas in reality there was a football but the machine either detected correctly or it didn't. That is, it considers true positive cases, there was a football in reality and the model predicts it correctly. False negative says that there is a football but model don't predict it correctly. So to take these into account, we will go for recall. Fraction of positive cases that are correctly identified. There are more positive cases but some of them are correctly identified. Prediction is yes, reality is yes. So this is the scenario of true positive. This is this comes perfectly. And if you go for the confusion matrix again, so I will write here prediction no, yes, and in reality also no and yes, and we will make it, and we will consider what? Last column. So what is the first column value? That is t n, true negative, and there this cell value is what? That is false negative. This cell value is false positive. This cell value is true positive. So for recall you need to take the last column in the denominator, that is fn plus fp. Here it is taking false negative cases into the consideration. Let us see the formula of it. True positive cases upon true positive plus false negative, that is tp upon tp plus fn. So this is the last column of our confusion matrix. There we go. Now as we notice, we can see the numerator in both precision and recall is same, true positive, but in denominator precision counts the false positive while recall takes the false negative into consideration. So in denominator tp plus fp for precision, but for recall it is tp plus fn, and it gives a good idea about the false negative cases also. F1 score, the measure of the balance between precision and recall, because now you have two parameters, which one to take, there is a problem. So for that they have created a new parameter that is called F1 score, and it measures the balance between precision and recall. So before going deep inside the F1 score, we must first understand its definition. It is said that the balance between precision and recall, as we didn't know which metric is more important, that's why we are seeking F1 score, because हमें precision और recall में से नहीं पता कौन ज़्यादा महत्वपूर्ण है, तो हम क्या करेंगे, F1 स्कोर को फाइंड आउट करने की कोशिश कर रहे हैं. तो F1 स्कोर क्या है एक्चुअली, it is 2 into precision into recall upon precision plus recall. Remember, in numerator you have multiply, and in denominator you have what, addition. Which metric is important, how to choose? Choosing between precision and recall depends on the condition in which model has been deployed. Okay, in cases like forest fire, the false negative can cost us a lot, because if there is a fire and our system will say there is no fire, this is a case of false negative, and whole forest is going to be destroyed by the fire, or fire may become such that you cannot control on that fire more. ओके, तो इस केस में हमें फॉल्स नेगेटिव का कॉस्ट बहुत ज़्यादा है. इमेजिन नो अलर्ट बीइंग गिवन even when there is a forest fire, the whole forest might burn down. So in that case, where false negative is very important, so which one you will take? You will take the recall, because recall takes into consideration the false negative cases. Another case where false negative can be dangerous, like viral outbreak. Imagine a deadly virus has started spreading, and the model which is supposed to predict the viral outbreak does not detect it, and the virus might spread widely and infect a lot of people. We have seen how dangerous a virus can be in the case of coronavirus. So अलग अलग केस में precision and recall, both different metric may be important. Let us move to the next slide. There we go. Cases of high FN cost, like forest fire or viral outbreak. Cases of high false positive cost, like spam. स्पैम, अगर कोई चीज़ नहीं है और उसको स्पैम में क्लासिफाई कर दिया तो क्या होगा, मेल वो आप पढ़ेंगे नहीं, बिकॉज इट विल गो इनटू द स्पैम फोल्डर, और आप हो सकता है कि वो ज्वाइनिंग लेटर हो आपका, तो किसी व्यक्ति का कैरियर भी खराब हो सकता है. तो यहाँ फॉल्स पॉजिटिव केसेस प्रॉब्लमेटिक है. स्पैम क्या होता है, ऐसे मेल्स दे माइट कंटेन सम डेंजरस और सस्पिशियस डेटा इनटू इट और लिंक इनटू इट. तो जो आपने क्लासीफायर बनाया है, जो एआई मॉडल बनाया है, जो मेल्स को चेक करता है, ऑटो क्लासीफाई करता है कि ये स्पैम है कि नहीं, तो अगर उसने फॉल्स पॉजिटिव डिटेक्ट कर लिया, मीन्स ऐसे सही मेल को उसने बता दिया कि ये स्पैम है, तो वो स्पैम फोल्डर में चला जाएगा एंड यू आर नॉट एबल टू सी दैट. माइनिंग, इन दैट माइनिंग केसेस ऑल्सो, कि आपने माइनिंग के लिए कोई डिटेक्शन सिस्टम बताया और उसने बोला यहाँ पर प्लेटिनम है, बहुत सारा यूरेनियम है, आपने पूरा सेटअप मूव कर दिया और बाद में पता चला अरे हमारा सिस्टम तो फेल हो गया था, उसने तो गलत बता दिया यहाँ पर, तो हाई कॉस्ट होगी उसकी. तो ऐसे केसेस में जहाँ फॉल्स पॉजिटिव की हाई केस कॉस्ट है तो हम प्रिसीजन के लिए जाएंगे. ऐसे केसेस में जहाँ फॉल्स नेगेटिव की हाई कॉस्ट है वहाँ पर हम रिकॉल में जाएंगे. बोथ द पैरामीटर्स आर इम्पॉर्टेंट फॉर सम केसेस. तो उसमें हम क्या करेंगे, प्रिसीजन में क्या है, फॉल्स पॉजिटिव कंसीडर कर रहे हैं, और हाई प्रिसीजन और हाई रिकॉल में क्या है, फॉल्स नेगेटिव कंसीडर कर रहे हैं. टू कंक्लूड द आर्गुमेंट, वी मस्ट से इफ वी वांट टू नो if our model performance is good, we need these two measures, recall and precision. For some cases you might have a high precision but low recall, or low precision but high recall. Okay, so since both the measures are important, they need for a parameter that takes both of them into account, like precision और recall दोनों के अच्छे गुणों को समाहित करके हमें कुछ दे, तो वो है हमारा नया पैरामीटर जिसको हम बोलते हैं F1 स्कोर. लेट अस सी व्हाट इज F1 स्कोर. इज an ideal situation would be when we have value 1, like F1 score will vary between 0.0 to 1.0. that is 100% for both precision and recall. In these cases, F1 score would also be ideal as 1. It is known as the perfect value for F1 score. As the value of both precision and recall ranges from 0 to 1, F1 score also ranges from 0 to 1. And high F1 score maintains the balance between precision and recall. In conclusion, we can say that a model has a good performance if F1 score value is high. Like if you are having F1 score value like 0.8 or 0.7 or 0.9, that is called good F1 score. At last, I want to say uh, again that same golden statement: arise, awake, and stop not until the goal is reached, by Swami Vivekananda. Thank you very much for patient listening. Please do like, share, and subscribe my channel if these videos are helping in your studies. So, guys, have a nice day.